Hello, this is Module 3, Investigation 6, Inverse Function and Reversing the Process. So, number 1, the formula that determines the perimeter of the square P in inches when the square side length S in inches is known as P equal to 4S. Okay, so if you want to find out the perimeter of the square, because square has about all four equal sides, right? So problem is add all s together, which is a 4s, right? So that's what they talk about. So A, what thinking is involved in determining the side length s when the p equal to 20. So you have a given parameter 20, right? So you already know the parameter. So p equal to 4s, but parameter is already 20. But the square must be all equal for size, so we just need to find one side. That'll be the the size for the square, right? And so for s equal to 5, isn't it? So 5 inches. And then B, when we invert the equation 20 equal to 4s for s, this is one instance of the reversing the process of this formula. So use the same process to determine the side length of the square s given the following value, the square perimeter p in inches. So same idea, right? So now you got 36 is gonna be the 4s. So s equal to the 9 inches. And then 22 is a 4s, which is divided by 4 both sides. You get the 5.5 inches. And then 100 is equal to 4s divided by 4 both sides. You got 25 inches. So C, what process did you use to determine the square side length when a specific value of the square's perimeter P is known? So what do I do with to determine the square side of the length when a specific value of the square perimeter P is unknown? Actually, what I do was we divide the value of the square perimeter by 4. We divide by 4, whatever parameter we given, right? And D, generalize the process you engaged in when answering part B by writing a formula that will express the square side length as in terms of the perimeter P. So P equal to 4S, but we're going to rewrite the equation as, and we write the S in terms of the P. So we're going to isolate the P by the S by itself. So I need to divide by 4 both sides. So P over 4 equal to S. So nice form is S equal to P over 4. So this is another formula, which means what do you do? Instead of the P is whatever equal to 4S, we just say S equal to P. That's a given. So 36 divided by 4, 22 divided by 4, or 100 divided by 4. D, how is the formula P equal to 4S and the formula S equal to P over 4 related? Yeah, these are the same relation. So the two formula represent the same relationship between two quantities, which is one quantity is the square length side of the square length, and then the p means the perimeter, right? But input and output actually be the switch around, right? So that's we call the inverse, okay? So input becomes the output, out becomes the input, and then yeah, that's we call the inverse functions, okay? All right, so that's for number 1. And then I need to go to for number 3. So evaluate the G of 32, use above the image to explain how the value of the input, quantity 32, processed or operate on the by G. So G of P was P over 4. So G of 32 is 32 over 4, which come out as 8. So yeah, so you can get the side nicely, right? And then in a group or as a class, discuss how the function of fs of 4s equal to G of is related. Okay, so G is so we can say the G is the inverse of f, and also f is inverse function of the g. They are inverse function. And then C, what do you notice that how the input and output quantities for f and g are related is? So the input quantity of f becomes the output quantity of g, and the output quantity of the f becomes the input quantity of f, g. So they switch around, right? Okay, so use the function composition to evaluate the following. So what we need is, okay, g function is g of p equal to the p over 4. And then the f function is the s equal to 4s, okay? So let's see what we got. You'll see actually the surprise, okay? So f of 5, so I'll plug in f of 5, which is 4 times of s, which is a 5, which is a 20. And the 20 is parameter going to the g function, so 20 over 4, which is a 5. But don't you see it come out, you put the 5 and come out as a 5 because two functions are inverse. Okay, we'll do it again here. So now with the g function, so 25 is a parameter. So we put the 25 in g function as a 25 over 4, which is 25 over 4. I got 6.25, so 6.25. So now you put it in the 6.25 into the f function, so 4 times 6.25 times by 4, it becomes 25. So we put 25 and get the 25 out. So since the f functions and g functions are the inverse, whatever input you put in, it comes out as output too. Whatever input you put in, comes out as output too. Now E, first true or false? For the function f and g defined above f undoes the process of the g, and g undoes the process of the yes, they're the inverse, true. F, discuss in your group or class how the function f and inverse of the this is inverse notation, so it's not -1 degree, okay? So inverse that relate in the terms of process or operation they perform. So inverse function notation undoes the process of the function f. And then their input quantity and output quantities. So I said already, right? So the input quantity of the function is going to be the output quantity of the inverse function, and then the output quantity of the function is going to be the input quantity of the inverse functions, okay? All right, so that's number 3. All right, and then let's go to the number 9. So we already kind of did the problem earlier in as a number 9, okay? So the f of 0, so 0 is the input, isn't it? So you're looking for output for the f function. So input is 0, output for the f function is 4. So this is just a 4. Now this is the inverse. So when does the inverse do? The 3 is actually the output. Okay, inverse function putting the output, but that becomes input, kind of confusing. Okay, so this is the input if you put it, and output for the f function and output for the g function. Okay, but we don't have an inverse notation, so we just put it. Okay, so output. So there's a 3 for the output for the g function, which is the 3. You have to find the 3 from here. So that's output. So what is the input for the g function? So -1. So this answers are -1. And then this also the output as a g. So 0 is the output for the g. So output is right here, right? And then what's the input? 3. So that's a 3. And then this is output for the f function. So -1 is right here, isn't it? So what's the input? Which is 1, isn't it? Yeah, that's how you find it. All right, and then let's go to the number 13 to see what we get. So, okay, before we get number 13, I want to do number 12. Use a given table to evaluate the following, okay? So 3 is the output, right? So output 3 for the g function, what's input? So -1. So this is a -1. And the output for the g function 0, input is what? 3, right? And then there's no inverse notation in g, right? So this is input. So input 2 to use a g function -1, right? And then this becomes the output for the f function because it's the f inverse, right? So output is right here, right? And then what's the input, which is 1. And then 6 is output for the f function. So 6 is right here, right? And then which is you look for the input, so 2, right? So you have to say 2, right? But that 2 becomes the output for the g function. So right here, and the input is a 0, isn't it? So equal to 0. Alrighty, number 13. Note that the inverse relation is a function might not be the function itself because you know the definition of the function, right? So in order to be a function from the equation, each of the x value has to be the correspond to the exactly one value in y, okay? It can be 2. So let's do the parabola f of x equal to x squared functions we got here, okay? So we want to evaluate. So what is the f of 2? So I'm using the graph, okay? You can use the equation too if you want. So f of 2, which is what? 4, isn't it? What about f of -2? It's also 4 too, isn't it? So f of 2 is a 4, and the f of -2 is a 4. So it's okay. The problem is, so this one means on the table, x and y, isn't it? You got the 2, 4, but -2 also 4. But for the inverse, what I do is, the problem is, it's going to be the 4 goes to 2, and the 4 goes -2. That's a problem, right? Do you see the same 4 goes a different 2y value? Cannot be the function. So expression y, the inverse, that inverse function is not a function. Because inverse of 4 has 2 outputs, which are 2 and -2. So consider the g of x equal to x squared whether the domain of the g is restricted, which is we only use the positive this time, okay? And then number 1, x and y g is the inverse of the function. So g is the inverse of the function, yes. Because g function's inverse is a function. Because now we are looking for only this one, okay? Okay, it's a positive one. Because for each value of y also greater than 0, so then there is exactly one value of the inverse form. So write the formula of the inverse this time. So inverse of the form, so there's a step that you can write it here. So which is g of x was x squared, right? Okay. So in order to find the inverse, you have to put y equal to x squared, and then you're solving for x this time. Okay, so when you solve for x equal to plus minus square of y, and then the x becomes inverse notation of the y, and then since we only use x is greater than 0, right? So we only take the positive. So this is it. So as a domain, it's going to be the positive number only, and the range also the 0 to positive only. Okay, so that's all for number 13. Thank you for listening.